Okay, guys, I want to take a couple minutes to examine alternating current and compare it with direct current, specifically in respect to voltage. AC stands for alternating current, and DC standing for direct current. As you know, the plot of the signals here, an AC signal is constantly fluctuating in a systematic wave pattern, and the DC signal appears as a straight line. So let's examine that waveform a little closer here. Okay, let's think of AC voltage and how it's produced. If you recall, electromagnetism is a source of electricity. We take a magnet and revolve it around a coil of wire, an inductor, or we take a coil of wire and revolve it around a magnet in a fixed amount of time. If we graph that, we have a sine wave, a trigonometric function called a sine wave with respect to time. Starting at that 0 point, as our inductor revolves around our magnet, we reach a peak voltage in the 90-degree axis, and it comes back down at 0 voltage when we're at 180-degree rotation. When we reach 270, we now, respectively with time, are in a negative value, again at peak, and then coming 360 degrees for one rotation, we're back to 0. So with respect to time, for each rotation, we see a positive alteration in value, and we see a negative alteration in value, and we can graph that using the trigonometric function sine. Because that voltage is always changing or fluctuating, there's never a set value over a given amount of time. So when we look at AC voltage, we're going to be looking at three primary values. Or I should say, I guess, 4 values. We'll look at the peak value, which is the value from 0 to a positive peak. We'll look at twice that, which is the two alterations together, the value to each of the peaks, and it's just a double of the peak value. We call that the peak-to-peak value. So here you see that explained. Twice of the peak value is the peak-to-peak value, or this to this collectively makes up the peak-to-peak voltage. We're going to look at the average voltage value. The average of our sine wave is 63.7%. If we were to graph that out, and we call that the E average or V average value, 63.7%. But really, when we look at work done by the electricity, the average value doesn't account for what's truly effective. The usable effective voltage, or the value that we would use in Ohm's law when we're doing our calculations, is derived from the root mean square of this sine wave graph. The root mean square voltage, also known as the RMS voltage, is the most usable number when we look at our AC voltage values, and that is 70.7% of the peak voltage, or a 0.707 value. So you take your peak value, multiply it by 0.707, and you have your RMS, or effective usable DC value. Basically, RMS voltage is the equivalent of the DC voltage value. So keep that in mind when you're associating DC values and AC values. Make sure you're using the AC RMS value. The 120 volts that we get from our wall jack outlet is a 120 RMS stated value. It is actually not the peak value of the waveform being generated by our generators. Now, a couple things to keep in mind when you're working with AC voltage values and you're going between the different values are the simple relationships. As mentioned earlier, the peak value is half of the peak-to-peak overall value, and the peak-to-peak is twice of the peak value. It's a very simple understanding there. When you're looking at RMS and average values, a couple things just to keep in mind. RMS, because it's 70.7%, you take your peak value, multiply it by 0.707, you have your RMS equivalent. Now, if you double 0.707, that gives us a 1.414 repeating value. So when we have our RMS value and we need to convert it to a peak value, just take your RMS, times 1.414, and that gives you your peak value. Easy way of going in between. The average values, remember average is 63.7% of the peak value overall. So if you take your peak times 0.637, that gives you your average voltage. And when you need to find the peak value given an average voltage, take that average voltage times twice of 63.7 or 1.57, and that will give you your peak value. Just keep these in mind. This is a good reference tab that you can always come back to as we continue our studies with AC voltage. A lot of good information in here. These graphs might be able to help you out too.